We can connect systems thinking to several topics we have already covered in this class. You may recall that early on in this course, we used frames to understand stories of this kind. Now, this story is actually capturing some information about a system. In this particular system, there is a country with people and president. It also has geological faults as a result of which earthquakes occur that kill some people. So the components, the complex relationship between these components, and the complex processes that emerge out of those interactions between the components. Scripts, too, are related to systems thinking. Dining at a restaurant is a complex system. Once again, there are a number of components, relationships, interactions, processes, functions. And script is a knowledge representation that allows us to capture knowledge of a stereotypical dining experience at a restaurant. When we discussed diagnosis, at that time we talked about systems thinking a little bit more explicitly. To begin with, we said that diagnosis is identification of a fault responsible for a malfunctioning system. Diagnosis begins with the observed data about some system, validates our expectations of the behavior expected of it. The diagnostic task takes the data and maps it into a hypothesis about faults responsible for that behavior. What makes the diagnostic task so hard, again, is that there are a large number of components that interact with each other, and there's a complex behavior that emerges out of the interaction between those components. Just think of program debugging. Program debugging is hard because there are a large number of lines in the code, and these lines in the code interact with each other, and very complex behaviors, output behaviors, emerge because of those interactions.
So another good example of how diagnosis is a case of systems thinking is if we look at ecological systems. Recently, there's been a massive drop in the population of bees around the world. That's our data. Now, as it turns out, the cause for this drop in bee population is the presence of a poisonous substance in insecticides used in the past several years. However, we can't see the process of bees getting poisoned by this chemical. All we can do is infer it based on higher level interactions of seeing the bee populations drop and seeing a rise in this chemical. So in this way, there's multiple levels of abstraction in this process. There's the visible bee population, there's the visible use of pesticide, but there's also an invisible layer where the pesticide actually poisons the bees. So we have to discern the interaction between these multiple levels.
In any complex system, there will be many levels of abstraction, some invisible, some visible. The human eye or human sensors more generally can see only some of these levels of abstraction, the visible levels of abstraction. Systems thinking helps us understand the invisible levels.